All right, today we are going to cover section 7.3, which is surface area of composite objects. Let's first talk about what a composite object is. So a composite object is made up of 3D shapes that are connected to one another. So imagine a cube sitting on a cylinder, or a rectangular prism sitting on top of another rectangular prism. Whenever you have these 3D shapes stuck together to form a new shape, that's called a composite object. Let's take a look at a simple case of a rectangular prism. Here we go. Here's our rectangular prism. And we're going to have sitting on top of it another rectangular prism. There's another one right there. Okay, let's give some labels to our two rectangular prisms. We'll call the smaller one prism A, and we'll call this bigger one prism B. And let's give it some measurements. Let's say this is 3 centimeters. This part right here is 5 centimeters. And this part right here is 2 centimeters. And let's give some dimensions to our larger prism. We'll say this is 10 centimeters. This is 8 centimeters. And this part right here is 6 centimeters. Now, if I were to ask you to find the surface area of this composite object, you might be tempted to think, I'll just find the surface area of the top prism and find the surface area of the bottom prism and then just add them together. And you'd be on the right track. So let's go ahead and try that out. We'll take the first smaller prism, prism A, and let's go ahead and calculate the surface area. Now, you can do this by calculating the area of all of its surfaces, so the front, the back, the top, the bottom, the left, and the right surfaces. Or you can use that formula that I showed you last time, which was 2 times the length times width plus length times height plus the width times height, which essentially does the same thing. It just gives you the area of the front, the area of the top, the area of one of the sides, and then just doubles everything. So let's go ahead and plug in our numbers here. So 2 times 3 and 5 plus 3 and 2 and 5 and 2. So we're just calculating the surface area here. 3 times 5 is 15. 3 times 2 is 6. 5 times 2 is 10. And we would get 62 square centimeters. Okay, so that's the area of the smaller rectangular prism. Let's go ahead and calculate the area of the larger rectangular prism. So rectangular prism B. Again, we can use the formula. So the surface area is just 2 times the length times the width plus the length times the height plus the width times the height. And let's plug in our numbers. So our prism here has a length of 10, a width of 8, length is 10, height is 6, and width of 8 and height of 6. So 10 times 8 is 80, 10 times 6 is 60, and 8 times 6 is 48. Alrighty, we have the surface area of the bottom rectangular prism. So if we were to add this up, you might think, well, we're done. We have the total surface area of this brand new shape. But there's something that we're missing here. Notice that when you place rectangular prism A on top of rectangular prism B, parts of the surfaces are no longer exposed to the outside world, which means it's no longer on the surface. So what is that? Well, the bottom of prism A gets covered up, and it sits on top of a part of the top of prism B. And so there's two surfaces here that are affected, two surfaces that are now smushed up against each other. They're covering each other up, and they're no longer part of the exterior surface. And when we simply add the surface area of these two objects, we end up including those surfaces that are now no longer exposed to the surface. So let's find out the area of these covered up surfaces, and we'll deduct it from our total surface area. This is what's called the overlap. And to calculate the overlap, we simply take a look at what the shape is that's being covered up. We can see that it's the bottom of prism A. The bottom has a length of 3 and a width of 5, so we can calculate that 3 times 5 would give me the area of the bottom of prism A that's covered up. And remember, it's sitting on top of part of the top of prism B in the exact same shape and size. So this 3 by 5 rectangle is covered up on the bottom of A and the top of B. So this 3 times by 5, I'm actually going to double because both of those get covered up. So this gives me 30 square centimeters. And this is the part that is between A and B. If you were to glue these boxes together, this is where the glue would go, and this is the part that's no longer part of our surface area. So when we calculate our total surface area, we take the surface area of our first object, our first prism, plus the surface area of our second prism, and then we subtract the overlap. And then we plug that in. This was 62, this part was 376, and this part was 30. And so the new surface area, the total surface area of this composite object is 408 square centimeters. Okay, let's summarize what we've just discovered here. When finding the surface area of a composite object, we find the surface area of each object and add them up. And, so this part's important, subtract the area where they overlap. Okay, this applies to all types of prisms, not just rectangular prisms. So let's take a look at another example and see how that works. So in this example, we want to find the surface area, and we want to round the final answer to 2 decimal places. Okay. What we're going to do is we are going to have a rectangular prism, a box, your favorite. There you go. I hope you're all getting really good at drawing boxes now. And I am actually going to make this rectangular prism, I'm just going to make it a cube. I didn't do a very good job of drawing it, but let's just make the calculation real easy. This is a cube. All three sides are the same length. They are all going to be 8 centimeters. There you go. Okay, so that's shape A. Now, attached to it, I'm actually going to have a cylinder. I'm actually going to have it stick out right here. Just attach this side there. There we go. And this whole thing is 3 centimeters long. And this part right here is going to be 12 centimeters long. And this is going to be our object B. Okay, we need to find the surface area of this object. I'm actually going to move it over to the side so I can get all the calculations on the left side. Let's start with the first object, which was this rectangular prism, this cube, object A. Now the area of one of its surfaces, because all of its length, width, and height are 8 centimeters, well, the area of that surface is 8 by 8. And since it's a cube, and every single surface is the exact same size, well, we have 6 surfaces, so just multiply it by 6, and we are done. This works out to 384 squared centimeters. Okay, that surface area is done. Let's move on to the next one. The next one is going to be our little cylinder, which was tilted on its side. Okay, to calculate the surface area of a cylinder, we learned that there was a formula for that, and it says that 2 pi r squared plus 2 pi rh is how we would calculate the surface area. And so let's plug in our numbers. 2 pi, our r is our radius. Now don't be fooled, don't just grab whatever number you see and throw it in here. Think about it very carefully. What did I give you? I gave you 3 centimeters, but that's not the radius. If you take a look here, it's indicating that from the top of the circle all the way down to the bottom of the circle, cutting through the center, is 3 centimeters. That's not the radius, that's the diameter. To find a radius, you'd have to cut it in half. So watch out for things like this. Be very careful that you are in fact using the radius when you plug this into your formula. Okay, so there you go. There's r squared plus 2 pi. Again, r is 1.5, not fooling me there. And h is 12. Now, just like before, I'm going to recommend that you leave the pi until the very end. Okay? Now, when I work this out, 1.5 squared times 2 is actually 4.5. And then over here, 1.5 times 2 times 12 turns out to be 36. Okay? And then you can combine these if you like, but hang on one sec. Let's take a quick look at the overlap, and you'll see why I held off on combining those like terms. Let's take a look at the overlap. Now, what is the overlap? Well, it's where shape A joins with shape B. It's the end of the cylinder being attached to the box. So its shape is a circle. Okay? So the left end of that cylinder is a circle that's being covered up, and it's covering up a circle-shaped portion of object A. So we have two circles that need to be removed from our total surface area. So our overlap is going to be two of these circles. Pi r squared is the formula for a circle. And let's go ahead and plug in our numbers. Pi r 1.5 squared. So this works out to be 4.5 pi. Aha. All right, let's go ahead and do our total surface area now. Our total surface area is the surface area of each of our objects if they were completely by themselves. Add those up and then subtract the overlap. So object A had a surface area of 384. We need to add the surface area of our cylinder, which was 4.5 pi and 36 pi. And then we had to subtract our overlap, which was 4.5 pi. Well, conveniently, because we had to remove two circles and our surface area formula included two circles, these guys conveniently cancel each other out. Okay, so now we calculate 384 plus whatever 36 pi is, and that works out to be 113.097. There's actually more to here. Okay, keeps on going on. So we end up with 497.0973. Now, they asked us to round our final answer to 2 decimal places. I don't do any rounding until I'm at my absolute final answer. And once I get to there, I'm going to take a look at this number right here. Okay, because I want to round, I want this to be the last digit. So I'm going to take a look at 7. It's greater than 5, so I need to round this 9 up, which turns into a 10, which means my final answer is going to be 497.10 square centimeters. And there you have it. There is your total surface area. And that's how you do this for all types of prisms. You calculate the surface area of each of the objects if they were by themselves, add those together, and then simply remove the part that is overlapping, where the two parts join together. And that's how you find the total surface area. All right, that's it for today. See you in the next one.